A herd of wildebeests plods across Africa's Serengeti plain. The land is parched and dry, so they move towards greener pastures. They move slowly, mechanically, using as little energy as possible. Their bodies use energy stored in fat deposits, since there has been little food. Between drinking holes, their bodies conserve water by producing as little urine as possible. Body systems work together to help them survive this journey. Let's take a look at this awesome phenomena called homeostasis. Get your papers ready, wide right, skinny left, and I'll see you on the next slide. Homeostasis, or controlled internal conditions, is essential to survival. This also means that the interdependence of systems is also essential. Internal body conditions must not dramatically change, especially during times of stress, even for just a few minutes, as it could lead to death. We talked about all of the body systems separately, but they are all really interconnected. All of them work together to maintain homeostasis, or this stable internal environment. For example, your respiratory and digestive systems would be useless without your circulatory system to take the digested food and oxygen to the cells. Muscles wouldn't work without a nervous system to direct them, and a skeletal system to support them. All this work is to ensure homeostasis. The controlled environment within an animal's body is really a very nice place for its own cells, but it's also a really nice place for hostile invaders. Pathogens, or disease-causing organisms, love the steady stream of food, oxygen, and a nice body temperature. But they disrupt homeostasis by causing disease. Most animals have an immune system. The immune system must be able to distinguish between its own body cells and foreign invaders, though. Once it discovers others, it attacks them, and it works to restore homeostasis. Your body experiences this regularly anytime you feel sick or fight off an infection. You also hear about this if you ever read about organ transplants, because those patients must take medicines to keep their bodies from rejecting this foreign organ, even though it's extremely helpful. Vertebrates, along with arthropods and many other invertebrates, regulate many body processes using chemical controls. Endocrine glands are a part of that system. Endocrine glands regulate body activities by releasing hormones into the bloodstream. Adrenaline is released by the adrenal glands to help you deal with stressful situations. Insulin is released by your pancreas after you eat to help your body store the glucose that was once the pizza you ate for lunch. And melatonin is released by the pineal gland in your brain. This helps establish wake and sleep cycles, among other things. All of these glands and more, and the hormones that they produce, work to keep internal conditions stable 24/7. So two things are critical for homeostasis. The first, as we just learned, is the interrelationship of body systems. The second is being able to control body temperatures. This is vital for maintaining homeostasis, especially in areas where the temperature varies widely with the time of day or the seasons. But why? Body functions are greatly influenced by the outside or ambient temperature. Cold muscles contract slowly, making an animal slow to react. That's not good if a predator's coming for you. Conversely, if muscles get too hot, they may tire very easily. Controlling body temperatures requires three parts or components. First, the organism needs a source of heat. It can be internal or external, but they need a heat source. Secondly, the organism needs a way to conserve heat when the temperatures are too cold. And lastly, the organism needs to be able to eliminate excess heat when they're too hot. Structures in the body and behaviors will help the organism manage and maintain an appropriate body temperature. Let's look at how they do this. Ectotherms have body temperatures that are dependent on an external heat source, like the sun or a warm rock. Reptiles, amphibians, fish, and all invertebrates are ectotherms. And you see two examples right here. Ectotherms have a very low metabolic rate when they're resting. That means that they process their food or they use their food very slowly. So their bodies don't generate much heat. However, just like you and me, when they're active, their muscles generate heat. They have very little body insulation, however, aka fat. So excess heat is easily dissipated or lost to the environment. Activities like basking in the sun or on a warm rock or burrowing underground can help them cool off or stay warm, depending on the circumstances. In the diagram here, you see several different ways that they can heat up or cool down. An endotherm is an animal whose body generates its own source of heat. Birds and mammals are examples of endotherms. If we take a look at this graph, the ambient or outside temperature is along the bottom of the graph, and we see body temperature on the side or the y-axis. The ectotherm, their temperature raises as the outside temperature gets higher, but in the endotherm, their body temperature pretty much stays the same. Endotherms have a high metabolic rate, so they generate heat even when they're resting. This is why you can warm up your bed sheets on a cold winter night. Birds conserve body heat with insulating feathers called down. In this bottom picture, the down are the feathery feathers, or the fluffy looking feathers. All of these are examples, except for about the middle one there, are examples of down feathers. Mammals use a combination of body fat and fur for insulation, as we see in the wolves up here. Birds and mammals also need to rid their body of excess heat. This is done with activities like sweating, shedding, and panting, along with behaviors like burrowing or just resting where it's shady or near water. No system is perfect, but both of these systems, endothermy and ectothermy, allow organisms to survive and reproduce. So let's take a look at the advantages and disadvantages of each. Endotherms can move around easily, even when temperatures are cool or cold. Their bodies generate their own heat. Their bodies also conserve heat, so polar bears can swim in cold polar climates and penguins can survive harsh Antarctic temperatures. However, the high metabolic rate that generates all this heat needs lots and lots of food, so endotherms cannot go very long without food. Ectotherms, on the other hand, need much less food than similarly sized endotherms. In tropical climates, where temperatures do not vary much, ectothermy is very, very energy efficient. That's why Mitch, our class snake, can go weeks and even months without eating. One disadvantage, though, is that when the temperatures are cool or cold, ectotherm bodies take a long time to warm up. And remember, muscles do not work very well. They work very slowly when it's cold. So that's not good if you need to avoid a predator. This is why large lizards and large amphibians mostly live in tropical climates. There's little doubt that the first land vertebrates were ectotherms. Fossil record supports this greatly. But biologists are not entirely sure how and when endothermy evolved, but there is some evidence to suggest a few things. There's a good deal of evidence that suggests that at least some dinosaurs were endothermic. Feathered dinosaur fossils have been recently discovered, suggesting that they, like modern birds, used feathers for insulation. Current evidence also suggests that endothermy actually evolved twice at two different times along two different and distinct lines. It evolved once along the lineage of ancient reptiles that led to birds, and it evolved again along the lineage of ancient reptiles that led to mammals. As we discover more evidence, I'm sure these ideas will be refined even further, and it's always really interesting to study it. So let's take a look at what you should get out of this section. What have you learned? Well, you should be able to define homeostasis, and you should be able to give me examples of how body systems work together to maintain homeostasis in a given situation. You should also be able to tell me about the role of the immune system and the endocrine glands and how they help maintain homeostasis. And lastly, you should be able to compare and contrast ecto and endothermy. How do each of them function, and what are some of the advantages and disadvantages of each of them? That's all for this section, and in fact that's all for this whole chapter. So remember to write your summary and go back through and do your 6 questions. 3 level 1s, 2 level 2s, and 1 level 3 question. And as always, make sure you bring your notes to class. See you in class, guys.